All right, y'all. Welcome back. We are ready to do our next lesson, which is lesson 7 in our books in Unit 1, talking about computing with scientific notation. And again, we're focusing on the I can statement about expressing rational numbers and using a different way to write those same numbers. And why is that helpful? Well, we have to be able to express really large numbers and really small numbers in a different way, because that's a lot of work to write that all out. And we've already talked about scientific notation and how to write scientific notation. So today we're going to be doing some computing with scientific notation. And hopefully you know that computing simply means that we're going to be solving problems. So let's look at this first one. It says express 130 billion in scientific notation. Well, if I wanted to write this out, and what this 130 billion is the amount of spam emails that are sent every single day. 130 billion spam emails are sent every day, and that number is just too big to enter in your calculator. So you have to know another way to write that so that it will fit in your calculator. So if we wrote out 130 billion, and if I wanted to write that all the way out, here's 130,000, 130 million, 130 billion. That's how I would write it all out. And if you tried to get that to fit into your calculator, it simply wouldn't fit. So we use something called scientific notation. Again, you talked about that in lesson 6. Hopefully you remember that I want this number to be the front of my notation. So how many times am I going to have to move this decimal point in order to make it 1.3? Well, the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So because I moved that decimal point 11 times, my answer is 1.3 times 10 to the 11th. That signifies 130 billion. Now this next one says I want to round this to the nearest hundred, and hopefully you know that in this problem or in this number, this is my hundreds place. So I want to either leave that a 3 or I want to round it up to a 4, and the next number after determines that. If this number is 5 or above, then I round this to 400. If this number is below 5, then I leave it at 300. Well, since this number is above a 5, I'm going to round it up to 400. So 365 rounded to the nearest hundred is 400, and now I want to express that in scientific notation. Again, I want just the number without the zeros. I want just the number to be the start of my notation. And how many times would I have to move a decimal? Let's say that I had to put a decimal in. Remember, when there's not one, you add it at the end. And I would have to move it 1, 2 places to make 4 the start of my scientific notation. So the next says, the number 3 says, write a multiplication expression. I'm going to multiply this number and this number together. So I'm going to multiply 1.3 times 10 to the 11th, or 130 billion, times 4 times 10 to the 2nd. Now, down here it says I can combine the numerals in the front together in a set of parentheses, and I can combine the tens together in a set of parentheses. And then I can multiply the 1.3 times 4, and when you take 1.3 times 4 on your calculator, so I have 1.3 times 4, and I have 10 to the 11th times 10 squared. So 1.3 times 4, and be careful here, you know that this is a multiplication sign and that this is a decimal. Don't get those two confused. 1.3 times 4 on your calculator is a 5.2. And 10 to the 11th times 10 to the 2nd, well, hopefully you remember your exponent rules. I have the common base of 10. Because there is a base in between my exponents are not touching each other, I add them. So my answer is 5.2 times 10 to the 13th. Okay? Now, let's go on to the next page. We are right over here on example 1. This example looks very similar to what we just did. Pull out the numbers and then pull out the scientific notation and add the exponents together. Let's go ahead and do A right here. I'm going to pull out the numbers. So I have an 8.4 times a 2.5. And again, make sure you can that you know that this is multiplication, not a decimal point. And then I do the tens, the base 10. So I have a 10 squared times 10 to the 6th. Well, if I take 8.4 times 2.5 on the calculator, I get 21. And the tens, there's a common base of 10. The exponents are not touching, so I add them. So my answer would be 21 times 10 to the 8th. See that over here? Now, when I'm doing scientific notation, I don't want a number in the 10 spot. I want a number in the ones place only. I don't want a number in the 10 spot. So I'm actually going to have to move this decimal to the left one more place. So it becomes 2.1 times 10 to the 9th. And that would be your final answer. Go ahead and do B on your own. Stop the video and do B. After you've done that, go ahead and continue the video. All right, let's look at example 2. Example 2 has this population right here. And it says to estimate. Estimate doesn't mean to find the exact answer. It means find a close answer. Find an answer that's close to that. So I would probably want to round this to the nearest billion. So right now it's at 6,860,000,000. And I want to find the nearest billion, which would be 7 billion. It's about 7 billion. And if I saw how many times I had to move my decimal point over, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 7 times 10 to the 9th. And I am taking that times 3 times 10 to the 8th. So this says how many times larger. Anytime you see how many times larger, you're going to, or how many times, you're going to divide. So I have 7 times 10 to the 9th divided by 3 times 10 to the 8th. 7 divided by 3 is about 2.3. That's where they got this answer at. And then the common base of 10, and subtract your exponents. 9 minus 8 is 1. So it's 2.3 times 10 to the first power, or 2.3 times 10. Okay? Let's look at this one. Again, this is another example where you want to line up, hopefully up here. I want you to highlight this, star this, whatever you need to do. You want to, when adding or subtracting decimals in standard form, and this is huge because we mess up on this a lot. We get our lining up of our decimals incorrect, and then it gets our entire problem incorrect. So you have to line up the place values in scientific notation. Regardless of whether you're doing scientific notation or not, whenever you're adding or subtracting decimals, you must line them up. So I'm going to do one over here because I want you to look at it. Let's say that I have 9.4 plus 21.8. The decimal points have to line up whenever you do this. It would be so easy to write 21.8. But if you do this, you're going to get the wrong answer, because my answer should not be 115.8. That's incorrect. I lined up my decimals incorrectly. If I line them up correctly, I want the decimals to be in a perfect line together. This is how I would add these two decimals together. And again, my decimal goes in the same place in the answer. My decimal should be all along a straight line. And the correct answer would be 31.2, not 115.8. So the same with scientific notation. You have to keep everything in line. So if I have a 6.89 plus a 9.24, if I lined those up, first of all, this one is to the 5th power and this one is to the 4th power. So I want to make them both to the 4th power. In order to do that, I would have to move the decimal place 1 to the right because that takes away 1 from the 5th. So then I end up with a 92.4. That's where this 92.4 came from. So I'm going to add 6.89 plus a 92.4. When you do that, you get a 99.29 times 10 to the 4th. Now I can move my decimal point back over because remember, I don't want anything in the tens place. I don't want that number to be in the tens place. I have to have a number in the ones place only. So if I move my decimal point back over to the left, remember to the left, you're going to add to the exponent. If you move your decimal to the right, you're going to subtract from your exponent. So when I move my decimal to the left one place, I have to add 1 to my exponent of 4, so that's where I get the 10 to the 5th. Same with subtraction. This one is to the 8th power, this one is to the 7th power. I want to make them both to my lowest exponent. My lowest exponent between 8 and 7 is a 7. So I'm going to move this decimal place, remember, to the right, takes away 1 from the exponent, so I'm going to move 1 place to the right, which makes it 78.3 times 10 to the 7th. Leave this one, 1.161 times 10 to the 7th. Then I subtract the two. 78.3 minus 1.161 is a 77.139 times 10 to the 7th. And the bases, what you're taking at times is the same, so I carry that to my answer. And now, remember, I don't want a number in the tens place. I don't want this number here, so I have to move my decimal back to the left. When I move the decimal to the left, it adds to the exponent. When I move the decimal to the right, it subtracts from the exponent. So when I move it to the left one place, I add to the exponent. It becomes 10 to the 8th. All right, next problem. Last one, number 5. The problem here is that this first one isn't even in scientific notation, so I have to get it in scientific notation first. So if I had a decimal at the end of it, how many times would I have to move it to the left to make a number in the 1 spot? Well, the answer is 1, 2, 3, 4, 5 places. So it would be 5.93 times 10 to the 5th. And I'm taking that plus the 7.89 times 10 to the 6th. Again, I have the same problem, 1's to the 5th and 1's to the 6th. I can move either one. I can either make this one 10 to the 5th by moving this decimal place 1 place to the right, or I can make this one 10 to the 6th by moving this decimal place to the left. In this problem, they moved this decimal place to the left, which made this one a 10 to the 6th. Either way is correct. I could have very easily made this 78.9 and gotten the same answer. Okay? So I made this one 10 to the 6th. When I add a 0.593 plus 7.89, I get an 8.483 times 10 to the 6th. And that is my final answer. Let's do D over here and see if we've got this. Actually, I want to skip down and I want to do F, because I think F is a more challenging problem out of the 3. So the first thing I'm going to do is I want to make them both in a scientific notation. So I'm going to have to move this decimal place over, and I'm going to move it over 1, 2, 3, 4, 5, 6 places. So I end up with a 6.3 times 10 to the 5th plus a 2.7 times 10 to the, count again if you forgot, because I've forgotten how many times I moved it over. 1, 2, 3, 4, 5, 6 times 10 to the 6th. Now, I'm either going to make this one a 10 to the 6th, or I'm going to make this one a 10 to the 5th. It does not matter which one you change. I'm going to go ahead and make this one a 10 to the 5th by moving this to the right 1 place, because remember, when you move it to the right, it subtracts 1. When you move it to the left, it adds 1. So I have a 6.3 plus 27. And when you do that on the calculator, 6.3 plus 27 is a 33.3. This is now a 10 to the 5th. So it's times 10 to the 5th. But if you remember, I don't want a number in the tens place, so I have to move my decimal to the left 1. And remember, when you move it to the left, it adds a number to the exponent. So my final answer is a 3.33 times 10 to the 6th. Okay? Any questions you guys have on that? Make sure that you write it down and bring it to class so that we can talk about it. Okay? All right, that's all we're going to talk about today. Tomorrow we'll do some work on this and bring your questions to class. Have a great night, guys. See you later.